Hi everyone, this is Sahiti on behalf of Edureka and I welcome you to the session on SQL Joins. So in this session guys, we'll mainly focus on the different types of joins used in SQL. Now before I start telling you about the different types of joins in SQL, let me just take you through the topics for today's session. So we'll start today's session by understanding what is SQL and then we'll get into the main topic, that is what are joins in SQL. Once you understand what is a join in SQL, we'll get into the different types of joins in SQL, and finally, I'll end this session by telling you some most common questions asked about joins. So I hope I'm clear with the topics. Alright, so that's great. So now let's move forward with the first topic, that is Introduction to SQL. Now, in the era of 2.5 quintillion bytes of data being generated every day, data obviously plays a crucial role in decision making for many business operations. Now, this quite quintessentially makes us handle data in various kinds of databases, and this very much gives us the need of using different kinds of databases. Now, in today's market, there are various kinds of databases like the relational database, the hierarchical database, the network database, and the object oriented database. But yes, SQL is the core of relational database which is used for accessing and managing the database. Now, if you're someone who is looking forward to learn about SQL and get started with it, you need to definitely understand the concept of SQL joins. So, in that note, let's get into the next topic for today's session, that is what are SQL joins. So, if someone asks you what are joins in SQL, joins in SQL are commands which are used to combine rows from two or more tables based on a related column between those tables. The joins are predominantly used when a user is trying to extract data from a table which have one-to-many relationships between them or many-to-many relationships between them. Joins in SQL are basically commands, guys, by which you can join two tables and you can get the rows of two tables based on a related column. Now, if you ask me what are the different types of joins in SQL, there are mainly four types of joins in SQL. That is the inner join, the left join, the right join, and the full join. So let's look into each one of them one by one. Starting with the inner join is a type of join that returns those records which have matching values in both the tables. So if you consider table A and table B and you apply an inner join on both these tables, then all those records would be returned which have matching values in both these tables. So for our understanding, I'm going to consider two tables, that is the employee table and the projects table. So when I apply the inner join on the employee table and the project table, all those tuples which have matching values in both the tables will be given as output. So the syntax for inner join is as you can see on the screen, that is select table 1 dot column 1, table 2 dot column 2, table 2 dot column 1, and so on. So basically these are the various columns that you want to retrieve from the respective tables. From table 1 inner join table 2, that is basically you're applying the inner join on table 1 and table 2, and then you have to mention the related column. So that will be mentioned after the on statement. So you'll mention inner join table 2 on table 1 dot match in column name is equal to table 2 dot match in column name. So if I have to just repeat the syntax for you, it's select all the columns, basically whatever columns that you need, from table 1 inner join table 2 on table 1 dot match column name equal to table 2 dot match column name. So if you want to see how inner join can be applied practically, let's move on to my MySQL workbench where I've created these two tables, that is the employee table and the projects table, and let's apply the join statements on both these tables. Okay, so before I move forward with this, let me just open a new query tab and let me just clear all the action outputs. So now what I'll do is I'll just write a statement, that is select star from employee. Right, so I'll just execute this particular statement and you'll see that you'll get the output as all the details from the employee table that I've already created. I have around 5 rows with 5 employee IDs and their first name, last name, age, email ID, phone number, and address feed it into this table. So similarly, I'll show you the projects table. Right, so let me just remove this and let me type in project and just execute this particular statement, and you'll see the different column attributes in the project table. So as you can see, I have the project ID, the employee ID, the client ID, project name, and the project start date. Client ID can be basically considered for all those clients, so you can have a separate table for the client IDs. So guys, if you see in both these tables, there's a matching column, that is the employee ID, right? So the basic relation between both these tables is that a specific employee having a specific employee ID can work on n number of projects, right? He can either work on the project number 1, 2, 3, 4, 5, 6, and so on, right? So as you can see, my employee ID 3 works on two projects, that is the 333 project and the 444 project. And similarly, you can see that, there are employees with the employee IDs 978, but yes, their information was not present in the employee table, right? So let's apply the join statements on these tables and understand what we get as output. So initially, I had explained you what the inner join was. So when you apply inner join on two tables, you can clearly see that, you get matching values from both the tables. So what I'm going to do is I'm going to apply inner join on both these tables. So for that, you simply have to write a query. So what I'll do is I've already executed it before. I'll just copy and paste the query over here so that I can explain it for you guys. So what I've done is I've just selected the employee ID, the employee first name, the employee last name, the project ID and the project name to be retrieved from both the employee and the project tables. And then I've applied an inner join on the employee and the project table. So for that, I've just written a query as you can see on the screen. It's select employee.emp ID, employee.emp name, employee.empl name, that is basically the first name and the last name. Then project.project ID, project.project name. From employee in a join project on employee.emp ID is equal to project.emp ID, because emp ID is basically a matching column in both the tables, right? So let's just execute this particular query. So when you execute this particular query, you can clearly see that all the matching values from both the tables have been retrieved. That is basically all the employees working on a specific project and their respective employee ID, employee first name, last name, project ID, and the project name has been retrieved. So guys, that was about inner join. Now let's move forward to our next type of join, that is the left join. Now as you can see on the screen, now the left join or the left outer join returns all those records from the left table and also those records which satisfy a condition from the right table. So if you consider table A and table B as two tables on which you want to apply the left join, then table A would be considered as the left table and table B would be considered as the right table. And when you apply a left join on table A and table B, you'll clearly see that, all the records from the left table would be retrieved and also the records which satisfy a condition from the right table would also be retrieved. Also, let me tell you that, the records which have no matching values in the right table, the output or the result set will contain the null values, right? So basically, if you have around 3 rows from the left table which have no matching records from the right table, then those records will have null values. So the syntax for left join is, as you can see on the screen, it's just similar to inner join. You just have to replace the word inner join to left join. You can change the syntax like, select table1 dot column1, table2 dot column2, and so on. That is basically the different column attributes that you want to retrieve from table 1, and then left join table 2 on table 1 dot matching column name equal to table 2 dot matching column name. So guys, that was about left join. So now let's just again shift back to my MySQL workbench, and then I'll show you how you can apply the left join. I'm just going to use the similar query. So what I'm going to do is I'm going to retrieve the first name, the last name, the project ID, and the project name from both the employee and the project table, and then apply a left join on it. So for that, I've written a query as you can see on the screen. That is select employee.emp name, employee.empl name, project.project ID, project.project name. From employee left join project on employee.emp ID is equal to project.emp ID, right? So basically that is because, this is the matching column between both the tables. So I'm going to just execute this particular query. So once you execute this query, you can clearly see the output. All the records from the left table, and for those records which do not have any matching record for the right table, we have a null value present. So if you remember, we had 5 employees in the employee table, right? So basically that was Vardhan, Himani, Ayushi, Swati, and Hemant. And if you remember, Ayushi worked on 2 projects. So both the project details are present over here, and Hemant worked on no project, right? So since he worked on no project, the values present in the project ID and the project name are null values by default. So guys, that was about the left join. Now let's move forward to the next type of join, that is the right join. So the right join or the right outer join returns all the records from the right table and also those records which satisfy a condition from the left table. So I know guys, this sounds quite similar to the left outer join. Yes, it definitely is. The only difference between both of them is that, the right outer join returns all the records from the right table and also the records which satisfy a condition from the left table. Coming to the left outer join, the left outer join returns all the records from the left table and also those records which satisfy a condition from the right table. So it's just vice versa of both of them. And also, the records which have no matching values in the left table, the output or the result set would contain the null values. So guys, that was about the right join. Now the syntax of right join is, as you can see in the screen, it's again really similar to the left join. It's simple. It's select table1.column1, table2.column2, and so on. So basically all the column values from both the tables that you want to retrieve. From table 1, right join table 2 on table 1 dot matching column name equal to table 2 dot matching column name. So the only difference between syntax, if you've seen the three joins that you saw till now, was the word inner, left, and right. Else everything else would be same. So you just have to apply the same logic. So for that, what we'll do is we'll again shift back to my MySQL workbench. Now what I'll do is I'll just copy the query. I'll paste it over here again. And then I'll just change this word to right. So I'll just apply right join. Now I'll just execute this query again. So when we execute this query, you'll clearly see that, the employee first name, last name, project ID, and project name are retrieved from both the tables. All those records from the right table are being retrieved, and the records which satisfy a condition from the left table are also retrieved. But yes, those records which have no matching values from the left table have null values present in the record. You can clearly see that, Vardhan, Himani, Ayushi, and Swati worked on projects, and then they had their specific project IDs and project name. But yes, there were employees who worked on project 6, 7, 8, but their employee information was not present in the employee table. So that's the reason there's null value present in the records of 6, 7, 8 project. So guys, that was about right join. Now moving forward to a final type of join, that is the full join. So the full join or the full outer join returns all those records which either have a matching value in the left table or in the right table. So basically, if you consider table A and table B and you apply full join on both these tables, then it will return all those records which either have the matching value in table A or in table B. Now, the syntax for full join is really simple. It's again the same as the other three joins, but you just have to mention the word full join. So the syntax is select table1.column1, table2.column2, table2.column1, and so on. Basically, the different column attributes. From table 1, full join table 2 on table 1 dot matching column name equal to table 2 dot matching column name. So that's basically again the related column, that is basically a matching column. Now to see how full join works, let me just shift back to my MySQL workbench. Now let me just tell you one thing over here. Now since I'm showing you how to apply joins on SQL, let me just tell you that, on MySQL, the full join is not applicable. So that's the reason, since I'm showing you on MySQL workbench, the word full join will not work. To just show you the working of full join, I'm just going to use the word union in between both these queries. So what's going to happen is we're going to retrieve all the values from the left table and the matching value to the right table, that is through the left join. And then we're going to union it with all the matching values from the right table and also the values which satisfy a condition from the left table. So this is nothing but full join, but since we're working on MySQL workbench and the word full join doesn't work, so I'm going to just use the word union. I'm just going to retrieve the project ID, the employee first name, and the employee last name. So what I'm going to do is I'm going to just execute this particular query. So when I execute this particular query, you'll clearly see that, we're getting all the values from the left table which satisfy a condition from the right table, and also all the values from the right table which again satisfy a condition or match the values from the left table, right? So if we consider the first left join condition where we got all the employee details and the project details, you'll see that, we've got Vardhan, Himani, Ayushi twice, Swati, Hemant, and their respective project details. Since Hemant did not work on any project, the project ID was null over here. Now, similarly, if we consider the output for the right join where, we took all the records from the right table and took matching values from the left table, we saw that, for the project IDs 666, 777, 888, there was no employee information present, right? So that's the reason we have null values over here for employee first name and employee last name. So guys, that was about full join. So I hope you've understood the different types of joins. The syntax is really simple for all the different types of joins, guys. You just have to change the word in all the different types of joins. For inner join, you use the word inner. For the left join, you use left join. For the right, you use the right join. And for the full join, you use the word full join. So if you just want to apply left join, what you simply do is you mention all the columns. That is, you mention the keyword select and mention the table name dot column name. And then you mention from table 1, left join table 2 on, and then you mention the matching column names from both the tables, right? So you mention table 1 dot matching column name equal to table 2 dot matching column name. So guys, that's how you can use the different types of joins. I hope it's really clear to you guys. If you have any further queries, then you can definitely let us know in the comment section. Now that you know the different types of joins in SQL, let me just cover a few important questions that are generally asked in interviews about joins. So the first question is, what is a natural join and in which situations is a natural join used? A natural join is also a join operation that is used to give an output based on the columns in both the tables between which the join operation is implemented. So that's what a natural join is, guys. It basically aims to give you output based on the columns between which this join is applied. Now basically natural join is used when you want to make sure that the number of columns returned are less. So for example, if you see on the screen, we have two tables, right? That is table 1 having two columns and table 2 having two columns over here. Now table 1 had column names column 1, column 2, and table 2 again has column names column 1 and column 3. Now if you apply a natural join on both these tables, you'll clearly see that you'll get an output as column 1, column 2, column 3 and the respective records. But in the same scenario, if you apply an inner join, what you will clearly see that you'll get an output like 1 dot column 1, that is basically for table 1 dot column 1, and then 1 dot column 2, that is table 1 dot column 2, and the respective records would be stored. Now if you see over here, you'll clearly see that when you apply the inner join, you'll have a redundancy of data. That is the column 1 data is getting repeated again, that is basically it is repeated twice, but in this case of natural join, it's just mentioned once. So this was a scenario of two tables where the output was so simple. But yes, if you look into a daily basis where database administrators deal with n number of tables and then they want to apply the join operation on these two tables, you'll clearly see that if they apply an inner join, then that would create a lot of problem of redundancy of data, and obviously more number of columns would be generated. But yes, in the same scenario, if they apply a natural join, the number of columns would be reduced at a maximum extent. So that's the situation, guys, where you apply a natural join. So if you're ever asked, in which situations do you apply a natural join, you can just answer this question by simply saying that, you can apply a natural join when you want the number of columns to be less. So I hope I'm clear with this point. Now moving on to our second question, that is how to map many-to-many relationships using joins. Now it's a known fact that the joins are basically used to map one-to-many relationships. But yes, if there's a confusion, how to map many-to-many relationships, let me just tell you that you need to use two join statements. So to explain you why two join statements are required, you can consider a scenario where you have three tables, that is the employee table, the projects table, and the technologies table. Now let's assume that each employee is working on a single project. So this obviously means that one project cannot be assigned to more than one employee. Now similarly, if you consider a project can be based on multiple technologies and any technology can be used in any number of projects, this kind of relationship is basically a many-to-many relationship. Now to apply the join operation on the many-to-many relationships, what you can simply do is you can have three tables. That is the projects table and the technologies table itself. So basically these are the two tables which have many-to-many relationships between each other. And also we can have an extra table, that is the project to technologies table. Now the project to technologies table will hold the combination of project and technology in every row. Now let's say we have a project A. Let's say this project A has three technologies, that is DevOps, microservices, and Hadoop. Now you have to map these technologies to the project, right? Now this project to technologies table will hold a record of every project technology combination. So it will hold a record of project A to DevOps, and then project A to again Hadoop, and project A to microservices. Similarly, it will have n number of records for n number of projects and m number of technologies. So this table is really important in this scenario. And this table basically aims to map the item on the projects table to the items on the technologies table so that multiple projects can be assigned to one or more technologies. So now that you have three tables, that is the projects table, the technologies, and the projects to technologies table, you need to use two join statements to link all these tables together. That is, use the first join statement to join the project to technologies to projects table, and then we have to use the second join statement to join the project to technologies table to technologies table. Now this is how all the projects and the technologies which have a many-to-many relationships between them will be linked with each other. So it's really simple, guys. Whenever you have an end-to-end relationship between two tables and you want to apply a join operation between these two tables, you just have to create another table, which can have all the combinations of the previous table, and then you apply a join operation from table A to table C and then table B to table C. So I hope I'm clear with this point. Now let's move forward with our next question, that is, what is a hash join? Now hash joins are also a type of joins which are used to join large tables or an instance where the user wants most of the joined table rows. So whenever the user wants the most of the join table rows, or when you want to join two large tables, you basically use this type of join, that is basically the hash join. Now the hash join algorithm is basically a two-step algorithm. So it has mainly the build phase and the probe phase. So in the build phase, you basically create an in-memory hash index on the left side of input. And in the probe phase, you go through the right side of input each row at a time and then find the matches using the index created in the build phase. So hash join is again a type of join which is used to join large tables, and it has mainly two steps, that is the build phase and the probe phase. In the build phase, you basically create an in-memory hash index on the left side of input, and in the probe phase, you go through the right side of input each row at a time and find the match using the index created in the build phase. So guys, that was about the hash join. Now let's move forward with our next question, that is what is a self join and a cross join. So the self join, in other words, is a join of a table to itself. So this basically means that each row in a table is joined with itself. So when you apply a self join to a table, just remember that each row in a table is joined with itself. Now coming to cross join, the cross join is a type of join in which a join clause is applied to each row of a table to every row of the other table. So whenever you apply a cross join to tables, then just remember that a join clause is applied to each row of a table to every row of the other table. Also, when the where condition is used, this type of join behaves as an inner join, and when the where condition is not present, it behaves like a Cartesian product. So you just have to remember 2 points. The first point is that whenever you apply a cross join on specific tables, a join clause is applied on each row of a single table to every row of the other table. And also, when the where condition is present, this type of join behaves as an inner join, and when the where condition is not present, it behaves like a Cartesian product. Now let's move forward with our final question, that is how to perform join operation on three tables. Now if you remember in the previous questions, I had discussed a question where we understood how to map end-to-end relationships using join operations, right? So over there, if you remember, we used three tables, that is the projects table, the technologies table, and the project to technologies table. Now to apply a join operation on three tables, we use two join statements, right? That is to join table A to table C and then table B to table C. So basically, to apply a join operation on three tables, you need to use two join statements. So guys, with this, we come to an end of this session. I hope you found this session informative, and I hope you understood what SQL joins are. If you have any further queries related to SQL joins, please comment in the comment section below, and